Okay. So last week we saw. Oh, is this not the marked one? Just give me a minute. Let's see. Hmm. So I hope you last class we had seen this prompt engineering, instruction tuning, and reinforcement learning. And today we will see actually this PEFT. This is parametric efficient fine tuning. We have seen earlier. If you remember, we discussed about the LoRa and QLoRa when we were discussing about the quantization. So we'll go through that fast because we already have completed it. Just let me. Yeah. Okay. So till here we have done, right? So DPO, BPO, uh, and then GRP. Correct. So why do we do fine tuning is the first thing what we discussed when we were discussing about the QLoRa, and after that we discussed about the instruction GPT, correct? So if you remember last class, we discussed about the instruct GPT, which was which was trained to become in to follow instructions. Apart from it has been pre-trained from GPT. Okay, so pre-trained one to following instructions. Okay, so now next step. So reinforcement learning also, it will not be reinforcement learning. We always expect to be done on the complete weights. Okay, but fine tuning we can do it in a different way. So to reduce the load on your computation hardware, right? So that is the only reason we are going for this option, which is parameter efficient, right? Parameter efficient means it's not a big thing. It's just that you can optimize the parameters, right? So you can efficiently remove some of the parameters, or there are different ways, right? So it is like you don't fine tune everything, or you fine tune only partially. That both are same ideally. Mainly, you don't fine tune everything, or you fine tune everything in a limited way, right? There could be some logic. So that's the logic which we saw as LoRa, which is like fine tuning everything, but in a limited way. But how do you fine tune everything in a limited way? That's what we saw today. Also, we will see. Okay. So, and how in another way, like other ways are there, how we can reduce the parameters. Like, okay, there are billions of parameters. So, if I can reduce that, okay, I will tune only 1 billion parameters, then I'm already reducing the computation by one fourth, right? So if I consider that 4 billion parameters and I only have decided to go for fine tuning of only 1 billion. But here the question is which 1 billion? How do you choose it? Like what is the criteria for choosing? Okay, if I do uh, fine tuning of this particular 1 billion parameters of some logic, then it will give me the maximum advantage, right? So that is what is parameter efficient. Oops. Okay, sorry. Can you see the screen? Hello.
Yeah, yes, sir.
Okay. Okay. There
Yes,
was
sir, we
a
can.
screen change, right? Can you see that?
Yes, some code.
Ah, okay. Okay.
We-
Yeah. Okay, it was running at the back end. Okay, no problem. That was in the other screen. I think it got completed, so it got opened here. Okay, no problem. So coming back here, okay, what I was discussing was regarding the full fine tuning and partial fine tuning, right? So full fine tuning is the complete parameters. Full fine tuning, what we call here is vanilla fine tuning, which is like you consider like 4 billion parameters are there. I'm going to fine tune all the 4 billion parameter. Fine tune means I'm going to change the values, right? Update the values. So that is the fine tuning of vanilla fine tuning. Okay. So here what we are trying to understand. So you see this diagram. So you see the diagram here. So this is the pre-trained transformer. So you bring in the labeled training data set. Okay. So you have like, suppose here I have 4 billion parameters, right? That's what I was talking about. So you are fine tuning all the parameters and then you bring the fine tuned transformer. Okay. This is the stuff in that. So now this is called this is like zero uh, parameter fine tuning. So in fact, prompt engineering is itself fine tuning only. So it's just real time fine tuning. So okay, so you're not updating any of the weights, but just that you are ensuring that you are changing. If you are given only the prompt, like for example, you are asking this one, right? So if this is the prompt, so this is the actual requirement, right? But when you will give like this, 5 lines, then the answer is different, right? So there is a difference between this response and this response, correct? So that is what is prompting. So you are also getting a different results. So you are fine tuned the transformer, but the only thing is that it's not permanent. Permanent means you have not updated its weights. So again, if you ask the same question, you will get the same response, same old response. Suppose, for example, here you gave one. So this is the response, the input. Okay, this is your input, and this is your transformer, and this is your response. One, correct. So if you give uh, this response to your transformer, this is I2, you get response 2, correct. Here, what happens is again, if you give I1, you will get R1. Okay. Again, if you give I2, you will get R2. So you are getting a different response, but this transformer remains same. You're not updating any gradients that, but still we call it as a one of the ways of changing the response of the transformer without even changing the weights of it. Okay. So you can read all these things. This is very minor. So now coming to reducing the parameters. Okay. So we have two options, right? So one is that addition, add a small network, external network, right? So this is one way, like you can add some prompt based methods and adapter based methods are there. There's a very good diagram I have added last semester. It's there in the slide. We'll go through that also. Second one is reparameterization. Means reparameterization is the lower part, right? So you are neither adding some additional network. Okay, here additional network means, for example, this is your transformer. You are giving an input and there is an uh, output, right? So there's an output. Output or the response, whatever we call, right? So there is a response. Now, if I will say in addition, small network addition means I am adding a small adapter type. This is adapter based. Okay. Prompt based means you are adding it in sequential or whatever is the. We'll see there are different methods in prompt based also. Adapter based is only one method, so it's very easy. So it is just that you are adding additional weights. Okay. Additional weights to get to process this input. So only this additional part you will be fine tuning. Okay, you will not fine tune the main weights. Transformer weights remain same. So this may be like 4 billion parameters. Okay, so this adapter maybe it is just 1 million parameters. Okay, so this is very less, but you are adding it in such a way that it will change the response. Okay, so and this is you can try like there's an advantage of adapter based also. So in the original transformer is not touched, right? So whenever you want the original response, suppose some of the queries it's like I1, I2, I3 like this, right? So some of the queries are original transformer answers correctly. Okay. So maybe some queries are not getting answered. So for these queries, you can add this adapter and then get a different response. But for these queries, since the original transformer itself gives a correct answer, you don't need to add. So adapter is like plug and play. Okay. So that is one of the advantage of adapter. Another thing, so to be more precise on what I was mentioning here is, suppose if you say these questions were general questions. Okay. Any transformer, any LLM which has got pre-trained on a general books, right? So it can answer. But if this is your domain specific questions, right? For example, this is your, mm, we'll take Python. Okay. So suppose this is Python queries. Okay. So production grade Python queries. Okay. So in that case, this normal transformer will not be able to answer. So you have to add some specialist to it. Okay. So it is like plug and play, and then it becomes a little bit advanced in Python. Similar way, you have suppose C++. So you have some queries, C++ queries. So for this, you can have another adapter. So this is like adapter 1 and this is adapter 2. So you can plug this and remove this, and then you can send these queries to get the answer. Okay. So that's an advantage of adapter is like plug and play type, right? So you give, it's like something like you are giving a personality to it, like prompt only. It's
Sir, can
it's
I
a
ask one thing?
yeah, yeah.
Is it kind like putting some layer in front of transformer, or like otherwise I
You'll
see
see
it
that
as kind
there
of
is
a
a
rack.
diagram for that. No, no, no. This is not rag. This is you'll see the diagram. We'll wait for it. Okay. After that, your
Oh,
question will have already been answered. Okay.
yeah.
So prompt engineering, I already mentioned, right? So this is like few shot we say, right? So few shot means you are giving few examples apart from your the original question and the required answer. Okay. So these two remain same in all of them, but there is the examples. If you give more examples, it will be more logically, it will giving you answer. Okay. So this is one thing, one of the um point. Like, so here what we do is this is more of like you can also say it like a prompt catching, caching, right? So you would have heard about prompt caching, right? So this is also something like that. Okay. Mm, okay. What is talking about? Okay. So here, so in this, what we do instead of having the prompt as a text, okay, instead of having the prompt as the text, we are having it in a soft tokens. Okay, so soft prompts means it is embeddings. Okay, so what we do, so in your like, please listen carefully. So for example, you have a transformer. Okay, so you give an input, you give it gives a response. Correct. So what we do in this soft prompt is uh, okay, let me come to the previous one. prompt engineering. Okay, in prompt engineering, what we do, we give a static prompt, right? So we give some instructions along with this original query. Okay, and then you give a revised answer. Correct. So the answer will be different when you give an additional information. Correct. But this is by words. Correct. So what is prompt engineering? We play with that words, right? So you modify it into a more elaborate instruction. You modify into a more like or more professional, or you wanted to shorten it. So you do all kinds of stuff, changing the structure or the words of the prompt. So this you do manually, correct? So instead of this, I say that, okay, see what it does in transformer, what it does is it takes this prompt and then first converts it into an embedding, correct? So input also it does the same thing. The transformer does not do the embedding, right? So the embedding is done at this point. And then these both gets added and then goes into the transformer. Added means appended, not added. It is appending. Okay. So it gets appended and then goes into the transformer and then the response. So now what we are talking about in the prompt design is you are changing this part. This is the text part of that standard prompt. Okay. So you are playing with that. So you are trying to change the wordings, instructions, and then see, okay, what is the response? This is prompt design, what we were discussing. In prompt tuning, you do not know, right? So the transformer is something, see, it doesn't matter. You are speaking a very good English or you are speaking a very bad English. Even if you make some mistakes in letters, it will be able to understand thanks to the subword tokenization. Correct. So that's the logic. So transformer only understands this embedding, not even understands. It is going to process only the embeddings. You write a good English here or a bad English here, doesn't matter. Okay. So point here is instead of tuning this, why don't we tune this? That is the idea behind prompt tuning. Okay. So what we do here is we will take this embedding. We will suppose I consider some. So to start with, I'll write my own embedding. Okay, my own sentence. Convert this to an embedding. This is the starting point. Okay. Then I say, okay, let me make it a what do you say? Let me make it as a system. So I have this maybe 1,000 inputs I have. I know the corresponding 1,000 responses. Okay. So this is the set I have. Okay. So for every I wanted one. This is the predicted R, correct? But I know the actual R. So when I compare these two and generate a loss, correct? This is what we do it in neural network, right? So you have this is the golden data set, whatever we call, right? So golden data set or the data set. We simply call it as a data set only. Okay. So this is the data set. You have the input, you have the correct output, correct? I have 1,000 samples of both. Okay. Corresponding. Now I give one eye and then see the response, correct? And then I compare it with the correct response. This is the correct response. And I can calculate a loss using some objective function. It doesn't matter whatever is the objective. So using this loss, what I'm going to do is I'm going to update this. So I initially started with human understandable prompt getting converted into an embedding. So now the embedding is some number, right? So you do not know. It's just that your wordings have become a embedding. So now you just remove this part. Now it is only this embedding will be there. Whenever you give an your new every I will get converted into embedding, and you will include this part which you initially generated, and then your transformer will generate a response, and it you will compare that with your original response, and then you will calculate a loss. Correct? Comparison. It's an objective function. Simple, right? So now you will propagate this loss back to only this embedding. So you are fine tuning, you are going to update that embedding numbers. Don't think about embedding, it is just a matrix, right? For example, initial prompt, I had suppose 10 tokens. Okay. And our embedding size is 768. Okay. So this matrix will be 10 into 768 is the matrix. This is the number of you can call it as weights or something. This is the weights which I am going to fine tune. I am not fine tuning, changing any of the weights here. I am just changing the weights of the embedding. That is called as prompt tuning. Got it? So once you complete this training for all these 1,000 samples, all these 768 embeddings, 10 into 768 embeddings would have got it is not even embedding, it is some, um, it is an embedding shape. It will get changed, all the numbers will get changed, correct? So just for a play sake, if you will re-decode it into tokens to understand, okay, after fine tuning, what is this numbers? So embedding is always a representative of a tokens, right? So if you do decode it into tokens, no human will be able to understand the tokens at all. It will be a random characters. So which means, uh, what is the intuition is that you, as a prompt engineer, you sit for 10 years and write prompt, very nice prompt. That may not be the right prompt to be to get the best answer out of this transformer. The additional system prompt, what I was talking about. So I'll write it here. The system prompt, or the P, what I was talking about, I will write in the top. So this is the P, and this is your input queries, right? So it goes inside, has two embeddings, and then gets appended, and then goes inside the transformer, and then it gives a response. So this is a text part, right? So you sit as a prompt engineer, you sit and write as you can write as good as very good prompt, right? But that doesn't guarantee that this transformer is going to understand that the best way and then give you the most correct response for all these inputs. You had 1,000 inputs, right? So you had 1,000 inputs, and the responses what this transformer is going to give is equivalent to the 1,000 actual response, right? This is the original correct response. So whether this is going to be same or not, no human can write this prompt. But if you will, because humans can only prepare words, right? But instead you do like this, just that convert this embedding and then just remove this and then do this fine tuning method. Only you change this directly this. And whenever your new query comes, you just add this fine-tuned embedding numbers. It's numbers, right? So you can easily fine-tune this. And when you decode it, no human can understand. That's the point. So you can never write such a good prompt in which your transformer will be providing best answer. That's the intuition backend. But ideally, it is like a fine-tuning of the front part, which is appended to your original query, which will be sent to the transformer to get the best response. Okay, understood? All these slides are same thing. Okay, you can go through this paper if you want. So this is the point, right? So this is same like adapter, right? So again, you can have a translation task, one prefix, right? And this one prefix, and this one this place. Okay. So and else.
Sir,
See that.
I have one
Mhm.
question.
Yeah, yeah.
So this prompt tuning
Hmm.
depends on the model, right? Like different model will have like different, like for each
Correct,
model we
correct.
need to train, right? Because tokenization would be different. Also, sir, this length, I mean, will be of the vocabulary size, or like what will be, or it depends on the input. For example, you mentioned 1,000 input to 1,000 output, right? Uh,
No, no, 1,000 is your data set, right?
right.
Which input, which
So,
length you're asking? This length?
sir, you 10 into 768 you mentioned, right? So this 10 number,
Mm-hmm.
like how long it would be?
That is your, it is not mandatory, it should be 10. You can make it 20 also, 30 also. Accordingly, see, it again depends on how much computation you have, right? So you can have 10 tokens, 5 tokens, whatever impact it has to bring in that number, it will bring. It doesn't matter the number of tokens ideally. You understand?
Okay.
Because you have sufficient, suppose 10 tokens into 768. So this is not a very small number, right? Until your fine tuning data set is like millions. So if you have only 1,000 set, right? So if you have only 1,000 set of input and correct response, then I think 10 into 10 tokens, that is 10 into 768 should be sufficient matrix for fine tuning. Or you can increase to 20 and see whether it is helping or not. I feel 10 should be sufficient.
Okay. So, sir, this 10, 20
Mhm.
are like hyper parameters numbers which we have to set,
Yeah,
or
yeah, yeah.
it
It is
okay.
hyperparameter only. That is why I told you. So that is why, see, as a human to start with, there is no any rule here. I'm just telling, since I have also fine-tuned like that, I'm telling how we finalize this is just that you have some sample queries, right? So out of this, you take suppose first to five, and then you prepare one prompt. Okay, so one prompt you prepare, and then you send not all five, you just want send one. So this will prepare the embedding. This will prepare one embedding, correct? So and then it will anyway append. So all these logics happen inside the transformer. Append करके then you will send it to, you will get a response. This is the logic, correct? So this is the
Hmm.
embedding of prompt and this is the embedding of your input. All right. So as a human, you will be able to write this input for 1 to 5 sample of input. So by seeing these 5 samples, you know, okay, this is what the 5 answers I wanted. So let me write a standard input. Okay. So once you write this, you know, right? So maybe it took 16 tokens, for example. Okay. You have written. This is the starting point. Just convert this into embedding. And now forget this. Now forget this. Use this as your starting matrix. 16 into 768. Okay. So now you pass on all the 1,000 samples, get the 1,000 responses, compare it with RC, 1,000 RC, correct? This RC, and then you will calculate a loss, correct? So, and then you propagate this to update this 16 into 760. Simple. This is what I did. Maybe there is a way to calculate how much whether 16 is fine or not, something like that. Understand? And also
Understood,
this
sir.
ideally it depends on the amount of computation also you have, right? So 16 into 768 is nothing, but if you want to have like 1,000 tokens, if your input prompt is 1,000 tokens, then it will be like maybe you will require a good amount of GPU, right? Otherwise CPU may challenge. Got it?
Yes.
Hmm. Okay. So adapter, this is that was also one of the type of adapter, but we'll see actual adapter what the paper originally mentioned, right? So there was a paper in 2019 where they introduced this adapter logic. Okay. So if you see, it's a very simple thing, right? So it's a very small number of parameters. Okay. So near identity initialization. Initialization is identity matrix. Okay. So you will place it here. Okay. So how does adapter look? So it looks very more simple, right? So the actual adapter is this one. Okay, this is the adapter. So this is like you zoom this. Okay, so this is the adapter. Whatever you want, you can put. So it is like, say, if you see here, what do you see here? This is almost same as this part. Not exactly same. It's almost right. So inside feed forward network also it will look like this exactly. It's like you are adding a part of WO. So the what do you call the weights inside feed forward network is WO. Inside multi-head it is WQW QKV, right? V. So these are all the four weights inside attention heads. This is the weights which will be there in the feed forward. So this one W adapter weights you can call it as like WA. So this is almost similar logic as WO, right? Because this looks like in a feed forward only this and this will be there. This also will be there. This and this will be there. Non-linearity of course will be there, correct? But others also is getting added. That is what the point is. Okay, so it's like you are adding one more feed forward layer inside this. So it gives little more what do you call the um what is that, non-linearity. Okay, the non-linearity part is little more, and you are going to fine tune only this adapter weights WA. You're not going to fine tune this or fine tune on any of these three. Okay, so again you will have 1,000 inputs, and then you will this is just one layer. There may be like n layer of transformers. So for every layer you should have this. Okay, so this and this, so two adapters at every layer. So n layers means it is like 2 into n is the number of adapters. Okay, and at the suppose the last layer you are getting 10,000 are predicted. Okay, and for every input you already have you have the data set, right? So you will have the correct answer. So now you compare this with this, create a loss function, right? So and then you will use that loss function to update this weight and this weight in every layer. Okay, simple. Just that where what you are updating matters. Okay. Hmm. So you can read the paper, same thing. So again, same logic, you can create for adapter separately for each of the task, right? So for one task, like currently it is not so much valuable. Oops. Just give me a minute. Huh? Current is power is gone. They'll switch on the generator. Can you see the screen or it's black?
So screen is not visible.
Yeah, just give me a minute. Um, okay. Hmm. Was there any?
Yeah, sir. It's visible now.
Mhm. Okay, so this is the point. 425. Okay, we have time. So coming to the next one is the LoRa, which we already discussed. Okay, it's fine. Okay, in LoRa, so in the first two, what we saw in the prefix tuning or the prompt tuning, what we did, we added one adapter. So prefix tuning is like prompt embedding. Okay, and then you added it with your whatever it is. This is your input, and this gets added and then goes to your transformer. This gives your length. So this part you fine tuned in your prefix tuning or prompt tuning. Okay. So now coming to next one is the adapters. What we saw adapter, what we do, you get the input and whatever is the prompt you wanted to give. So you don't do anything. You get the embeddings, and then just I will draw the same way. So you get the embedding here, you get the embedding here, just add it. Then you send it to your transformer. Let me draw a big transformer block. Inside transformer, there are many blocks, right? So like this, and then you get a result. Oops, अरे यार पावर 2 मिनट के लिए क्यों कट करता है प्लान? Now the power has come back. I really don't understand why do they cut for 2 minutes? Okay, so can you see the screen now?
Yes, sir. Yeah, it's visible.
Okay, okay. So this is the response here. This is your transformer layers, right? This is the layer one, layer two, like that. Okay. So this is the complete transformer block. Inside this layer, there are some attention block, feed forward network, and there is an adapter. Okay. So that is what we have fine tuned here. Okay. So like that, every layer, there will be one part, one small part. Okay. The remaining parts we are not finding. Okay. So just I'll put lines. Remaining parts are same. Only this red boxes which we have additionally added. Adapter means we have added more. Okay. So that is important. So now in both the cases you see, we are adding new things, right? So this is not mandatory to be included, right? So here I have written, but that is not mandatory. You can just remove this also, right? But so that is why we almost call it as an adapter type. Okay, this is also, you don't explicitly call it as adapter, but still you can consider this an addition. Still now we have not touched the original transformer weights, correct? Even though we have put a adapter deep inside the network, but we have not touched the original weights. What is the original weights? Original weights are WQ, WK, WV, and WO. This belongs to that feed forward network, and this belongs to the attention layers. Okay. Direct neural network there. Okay. So these weights we have not touched. Okay. So this red weights are the can call WA. Okay. And this is WP, right? So to just you can call it anyway. Just I wanted to differentiate between. Okay. Now coming to low rank adaptation. Okay. This looks like adapter, but it is not not so much an adapter. It's like reparameterization, right? That's why we call it as a reparameter. It's neither an adapter nor a change in the original weights. This is like in between both. So what we do, this is your original pre-trained weights, correct? So this W is a, to call the what all is there inside W is Q, K, V, and O. Okay, for example. So nowadays there are a lot more weights, but in the old one, it was like this only. Okay, there were four weights which belongs to this W. Okay. We are not doing anything, but we are creating a replica of that. Okay. So replica means, so consider that this W in a simple form is a big matrix, right? So 4000 into 768, for example. Just for us, don't consider as an exact number. So just W is this much. Okay, it has all the four weights inside. So I create a the same logic. This is delta W, which also has to be same. So this is what we call, this is the W naught. So this W naught is different from this W naught. Okay, so here we call it as uh, let me just check what thing. Here it is different. This weight is W only, what we are talking. Okay, now currently for not just to reduce confusion. So this W is this W. Okay. So just leave that W naught. Okay. So you are going to add some W, delta W, not you are not going to append it. In the other two cases, you are appending it, right? Here you are appending it, not adding it with this weights, right? These numbers. This embedding you are not adding, you are appending it. So it's like an additional tokens. So here you are appending, like it, you have to process it through that adapter. right? It's an appending of layers. But here, if you see, we are not appending, we are adding it directly. So if this is 4000 into 768, this delta W also is 4000 into 768. The shape will be the same. Okay. But if I am going to fine tune this much, then so it is, I can fine tune this only. Why I have to make a extra stuff, right? What is the use of it? So, and that is why what we are going to do is, instead of W, that is 4000 cross 768, we will create one low rank decomposition. So that is what is low rank adaptation. LoRa is low rank adaptation. So what we do here is low rank decomposition. It's a very simple logic, right? So in instead of this delta W, which is the shape is 4000 into 768. So I say that I have a B of 4000 into suppose 4, and I have another matrix of 4 into 768. This 4 is called as rank. Okay. So that is what low rank. So you are choosing a very low rank. How much ever low rank, that much ever less number of parameters, correct? So if you see here, it is like 4 into 768 is too much, right? 4 into 768 is 1000, right? So it's almost like 28, I think, 43,000, right? 3000 into 3000. So it is like 3 million parameters here, correct? But here you see 4000 into 4 is 16,000. 4 into 768 is around 3000 again. So 3000 plus 16,000 is only 19,000 parameters you are going to do, going to fine tune instead of the 3 million parameters what you should have done in the original run. But how will you convert this into this 4768 is just multiplication, matrix multiplication, right? So matrix multiplication, if you will multiply like this, and this is B and this is A. So when you multiply this, what you will get? You will get a like this, correct? So that's what is mentioned. Okay. So this is 4000 into 4, and this is 4 into 768. When you multiply these two numbers, matrix, you will get 4000 into 716. And this is your delta W. And this you will add it with your original transformer weights, which is W. And it's like adding means it's not always advantage, positive, right? So these weights can be +1, -1, something like that, right? So if you add, this will get added, this particular weight will get added, this particular weight will get reduced, right? So it is simply modification of your original weights, but you are not touching the original weights. You are just creating a new smaller weights. Only you will fine tune this. The multiplication of that added to your original weights is going to be used for the final weights. Okay. The final weight is this one. This is your final weight, right? Uh, what do you call this? This one, this plus this. This is your final weight. This is only you are going to use it for your calculation, for the inferencing. The transformer, when you are doing I, the transformer final weights will be W. Okay. How is this W calculated is from W naught and delta W. Instead of delta W, you use B and A to add it. Okay. And these two matrix you will fine tune. Okay. Understood? So in this, you don't need to change any structure of the transformer. You don't need to know anything about the transformer except the number of parameters actually give you. Okay. This is the LoRa. Okay. So you can again read all these things. So one thing what I wanted to highlight here is this part. As in the original transformer, if you see, they have, like I mentioned, right? WQ, WK, WV, and WO, right? All these four, if you append it, that is what we saw earlier, right? So they tried to understand which of these combinations of these four is giving maximum benefit in when you're using LoRa. That's the point. Okay. So what they found was this is the best for the uh, use case. Like they have mentioned in the paper, and you will see also. This becomes like this is very good, but the number of parameters are very high. Okay, but here it is very less because WO parameters will be very high. So when again depends on the uh, which is the best one which will come out of your as per based on your architecture of the transformer also, correct? But what they have mentioned is WQWE is best. Okay, so not ask this question in exam, but just for your knowledge. So because you will always have an option when you are doing LoRa, it's blindly people do it, and they normally do this. Okay, when you do blindly, but you can reduce that if you are intelligent enough to target only these two. And still, this you see, it's almost this is the same. This is almost same, right? So you don't need to worry even that okay, you will miss out something. So, but you have, if you know the depth of this, you can just remove this and this, and then you can fine tune more lesser than simply adapting LoRa. Okay, that is the one thing which I will expect you guys when you are doing LoRa training. Okay, anytime after this course. Okay, this is
So
one
what are these
revision. Quick,
numbers? Is it accuracy or what? These numbers, 70 or 90?
this one. Yeah, it
Yeah.
is all. If you go to the data set, you will understand. So these are all benchmark data sets, right? So when you run it over that, it will generate accuracy or whatever you want to say. It's not exactly accuracy. You don't call that in most of the DNA case, there is accuracy is not the correct word to be known. So you can call it as some perfect confidence level. Okay, some score is required, right? One number is required. So for any task in your Gen A, you need one number to understand, okay, your system works good, right? So that is the score. Okay, it can be
S-
anything based on that. So it's
Is
like
it compared to
wiki SQ.
the is
Hmm.
it compared to the base model that we had originally and then it improved by 73% is
No,
confidence
no,
or
no. It is not
can we?
improved. It is not improved. It is how well it is performing on this data set. Okay. So yeah, I think it is not written without that. I think it is written here. So you see here, this is the full fine tuning, correct? This is the full fine tuning. This much you will, this many number of parameters you will fine tune, and you will get this much accuracy, right? But when your accuracy or whatever is the number, and here you see you used LoRa and still you got that much number.
Mhm.
In fact, a better number. That's the point. Okay. So you can, point is it's not a comparison from the original one. The original one, why do you even compare? You will not compare it with the without training, right? So because without training is not going to perform what you wanted. So the requirement is to fine tune to make it perform. So original one you can consider it's zero on these two. Not zero, it will randomly maybe 10, 20%. But you're not interested in that, right? Because you wanted it to become a specialist. When you wanted fine tuning means you are telling that, okay, I want to make the model more specialist on that particular subject or domain. Correct.
Yeah.
But here, what we have to compare is what kind of finding. So now my requirement is okay. I have to like, for example, you are BTech, and maybe before this you were all BTech, or some people were BTech, and mm, you wanted to become a specialist in data science. You can choose to study MTech and become specialist. You can go and do a work in office in data science job and then become a specialist. The quality will be different. Both of them, the quality will be different. But there may be somebody like who does both, like you guys, like many of you, who are also working in office or who are also studying in MTech, or who some people it's just same thing. All those logics, the different logics to improve and become a specialist, whichever is the best. Okay, and whichever is the less investment or whatever is the logic. Investment, you can compare it with the number of parameters here. Okay. Okay. So these are all visuals. You'll be able to easily understand. So this is, if you see, this is the complete transformer. This is your input and this is your output, right? So when you are, it's a classification header. So it will classify, and then you are updating all the parameters of all the layers, right? All the layers, if you update, it is called vanilla fine tuning. Okay. Now comes the prompt fine tuning. Okay. Prompt or prefix tuning. Okay. So prompt tuning and prefix tuning is same. So prefix embedding. So this I already discussed, right? This is the input and this is your embedding in, and you will have a standard embedding, which is a static embedding, right? So whenever your input embedding goes, this will get appended to it. Appended means now instead of 4 tokens, it goes 7 tokens, right? So, and then you are giving. So this is also, you can fine tune for your particular task. Okay, task set. So it also gives a change in the response. Actually, prefix tuning. Oh, okay, I missed one point. Prefix tuning is not exactly same as prompt tuning. Prompt tuning means we are worried about only the first layer. Okay. So in prefix tuning, what we do, we can have it in every layers. Okay. So here in prompt tuning, what we did, only with the input embedding, you just append these 3 blocks and then send it. So there is no change in the further blocks. That's prompt tuning. And prefix tuning, you will train a prefix here, a prefix, same thing like prompt tuning. What you are doing for the first layer, you are appending it with the input, right? So at the first here into this in transformer, you are adding p and this prefix weights, correct? And then you are sending. But in prefix tuning, you are also doing it like, here there will be a revised input, right? So when your input goes, I and P will go inside transformer, there will be an I1 coming out, right? So when I1 comes out, you're also adding a P2 here. And then there will be an output as I2 for it. I2, I will not write. We always call this as second one. I call it as like I1 prime and here I1 double dash. Okay. So this is one, and then you add P2 here. So now in this, what happens? This P1, this also you are tuning, this also you are tuning, and this also you are tuning, right? So you have more number of tuning and you have control in all the layers. So in all the layers, when you have this kind of small blocks like embedding or say embedding, what is this? All these are numbers only, right? Matrix. So you're just adding a few more matrix and you're ensuring you're fine tuning it. So you can fine tune all. So here it is only the first layer. So it's almost same. It's only the in the input, if it is there, it's prompt tuning. If it is in every layer, it is prefix tuning. Okay. Adapter we already saw, right? So the same thing. You can put one small similar kind of feed forward network at 1 or 2 locations. It again depends. It's not like standard that you have to put here, you have to put here. So in GenA, everything you can do yourself. Okay. So if you understand, only I'm happy with putting here. Okay, you're adding it here. Or you can add here, or you can add it at both the place, or you can push it to front of this if you feel. Okay. Or you this also you can push it here back, right? So anything you want, you can do. See, adapter is in your control, right? So when you have the architecture, it is in your control how you build your adapters. But only thing you have to understand is adapter is some neural network. Okay, you have a projection down and projection up, and then you send it to use it as a the weights are getting trained inside this. Okay. Mm. So same thing. Can just go through this. Mm. Mm. Here what we are trying to say is like you are trying to do that. BA concept, right? So BA concept of LoRa. So you can have LoRa only for the feed forward network, or you can have for the your what do you call the other one? Mm, Attention layers also. Here they are showing only for feed forward network, the WO advertised. Okay, so it generally starts with WO, but you can also use everything as a matrix, right? So every weights at this point is a matrix. So you can make it a low rank matrices. Okay, so these are all additional things. Last year itself, this picture came. So there will be a lot more which has come currently. You don't need to remember everything. Just remember few of the things what we were discussing, right? So others are, if you want, you can go and read more. Okay. So thing what else? Attention tuning is only tuning the attentions, right? Attention layers, LoRa, QLoRa. Okay. QLoRa we already seen, but I think it will come again. We'll just quickly see. Okay. So this is the LoRa, right? So it should be all these just go through. Okay. So I think 1 week is there for you guys to read. If any doubts, just ping me. Okay. And this is one small calculation. How do you calculate the memory requirements when you are serving? Serving means when you are doing inferencing on a LLM. Okay. So what is the maximum amount of memory required, right? So when you load it on 16-bit, when you load it on 32-bit, right? So when you are doing, so originally is 32 bits, right? So when you are quantizing it to 16 bits, then the memory will decrease. Got it, right? So all the LLMs are trained at 32 bits, right? So when you will do quantization, you can do it to 16 bits. That's what is quantization, right? So that's what we saw. So from the original 32 bit, you can take it to 16, 8, 4, and this is the NF4, or even 1 bit B is there. It is from Microsoft, I guess. There is a paper on it. So you can read. It's a very interesting paper if you're interested. So normally we go till here, NF4. Okay. So this will be like almost 8 times reduction. 8 times reduction in the original memory. Okay. So see, this is one idea you can see here itself. So if you see here, so this was your original size, right? It's your original size, correct? So when you're doing inferencing, when you're doing inferencing means it'll be almost, it'll not be this much, it'll be a little more. Okay, it'll be approximate values. It again depends on what is the model. You cannot exactly see. It will be twice you can consider during inferencing. The worst case in general, you can consider 2 times for your memory requirement. In practically, I'm talking about it is these numbers are not just for reference. Okay, so 2 times you can consider for inferencing. If your model is 30 GB, consider 60 GB memory. And if you will do quantization, the model memory itself will get reduced to 14 GB. And your inferencing memory, you can consider again twice. So if you do int 8, then it is more or less what we are talking about, right? NF4. NF4, if you do, you will get to 4 GB. Original model was very big, right? 28 GB. But you can keep it in your laptop if you are 13, 16, 32 GB RAM, right? Not only RAM, I'm talking about the memory also, right? Memory, you can hold this also, but later when you are doing training and inferencing, you need this much into your RAM, right? And this is for training. This is like full training. Okay, so full all the weights, if you will. Okay. So approximately, this is 2 times means this is approximately you can take 4 times. Approximate. Okay. So if you have that much memory, CPU or GPU, you can tune. Okay. So you see this one, if you can do it in your laptop, it'll be very slow, but still you can do it. Okay. Uh, but this is full fine tune. So, but we normally what we expect was LoRa training, right? So LoRa training, you need only 5 GB RAM, right? So that is sufficient. So you pull the model, okay, and keep the model and then do a LoRa training. Only 5 GB RAM is required, but the model is very big, right? Understood? Any doubts you ask? Okay. Uh, it's all I have already taught. That's why I'm going fast. Just go through. This is a simple formula. Uh, because I want 1 hour for question paper discussion also, not question paper, topics for question paper. Okay. And QLoRa we already discussed, right? So how do we quantize it? So you can read about it. Any doubt, let me know, then I'll discuss. Okay.
Sir, just one
Yeah.
question regarding like how
Mhm.
actually we do it. I mean, for example, the adopter one, right? You
Mhm.
showed like within the layers we will have adopters, right? But in the code,
Mhm.
we get like the model, right? Which is everything. But if we build it from scratch, we can have like layers. Like how do we? Is there are like libraries or like how do we do that? I'm
No,
not sure.
whatever model you can fine tune, you should have the complete model. Until and otherwise, you don't want to do adapter training. When you want to do adapter training, you should have the complete model in with you because you have to add the adapter at that intermediate position, right? You do not have the
Yes.
complete skeleton. How will you add it where you want to add?
I mean, like, how do we do it? I mean, I don't like visually. I understood the concept, but uh, I wondered like,
See,
how do we actually do that thing?
that you have
For
to go
example,
and see.
if we
Have you done
yeah, so,
RNN training, LSTM
yeah,
training?
yeah, sir. RNN,
Have you done LSTM training?
LSTM, I'm not sure. Yeah, LSTM is similar with RNN, right? Yeah, I've done that. So
RNN,
in
you.
those like, sir, in those like we have like custom model, right? I mean, we define layers and we do everything.
Mhm, mhm.
But here we have a
Here also it is all
pre-trained model.
layers.
Okay.
No, no, no. Retrained model, right? See,
Uh-huh.
even in LSTM, what do? You build your model, right? So it is like
Right.
this, right? So, for example, more interesting is I'll take CNN. Have you done CNS training?
Yes,
You
sir.
have done, right? So in
Yeah.
CNN, what do? You take this is the image. You just build the first one. You give this is the input size, right? Input shape you will give, and then you will
Mm-hmm.
put another convolution layer, then max
Mm-hmm.
pooling layer, right? So convolution layer. So it is like this, right? So exactly this is what is transformer. This is how the transformer also comes. The only thing is what is there inside this is different. But only thing what you have to see is the this part is compatible with the previous part. This part is compatible with the previous part. So if I say I wanted to add something at this point, I should this input should be compatible with this output, correct? And same way, this output should be compatible with this input. Understood?
Oh, sir, I think my question was different. Sir, can we go back to the previous slide where you were explaining the doctor thing, maybe? Uh, so,
Mm-hmm.
so
Yeah,
basically,
tell
we
me, you tell
already
me.
have a model, right? Which we will get from somewhere.
When you are training CNN also, you will already have a model.
Sir, yes, is
You
asking
already have
about
a
coding part, I guess. How do we
what?
inject this? Yes, is asking about like coding part for this. How we inject this adapter in that? I
Coding
In
guess.
only
between
that I
layers,
explained,
because
right?
Like
So
for example,
actually,
sir,
sir,
adapters when you want to add, we don't own any model, right? For example, GPT-4 or 4.5, we don't own that model at all. So how can we
No,
add that
no,
adapter?
nobody can fine tune GPT-4 or 4.5 because you will not have the skeleton. You need the skeleton with you. You cannot fine tune every model out there. You understand?
so,
You
for
can
example, sir,
fine tune.
whatever is the open source model, I
Mm-hmm,
mean, whichever is available, in which we
mm-hmm,
have the skeleton, like we
mm-hmm.
don't want to train everything, right? Whichever model, for
Ah.
example, this
So in that
Meta
case, you have to
Llama, right?
understand the schema, right? So see, if you're doing
Acha,
prompt
acha.
tuning, you don't need to understand. But for if you are doing adapter tuning, you should know where to plug in, right? If you wanted to adapt, see, for example, like one statement I mentioned, GPT-4 or 4.5, you cannot fine tune, correct? That's not
Mm,
exactly correct. Why I will say that is because there is an option to fine tune in Azure. Okay. But what is that is they don't want to give you the model. Okay, they don't want to
mm,
show you how the skeleton they have built. Okay, that's the core heart of the models design, right? So what they
mhm,
did, they put an adapter here, they put an adapter here. Okay, they put an adapter here. They made one module. Okay, so this they have made it for you, and then they are just giving you, telling you, okay, you send me your data set, you upload a data set, and then call one library, and my library will get fine tuned. But
mm,
they have decided where to put the adapter. Okay. But
right.
that is not the right way to do it. Okay. If they say that, okay, if you put adapter at this point, that's fine. That's fine. Okay. I'm okay with that. But point is, in right way is you get the complete skeleton of the model and then start adding it, whatever you wanted, right? So that you can play with that. You can do a research on that. Otherwise, it is like if Azure is saying that, okay, Microsoft is saying that, okay, wherever I have put adapter, you have to go and fine tune only those. So they have set up this for you. Only that they will give one library, they'll tell you that is what people do. Like if you say everybody has done fine tuning, this is not the right way to do fine tuning. Only giving data set and calling a library, it is not ideally fine tuning, right? Somebody else has decided most of the thing. It's like you own a car means you have you have designed and built the car, no, right? So it's like that. So giving a data set and calling a library is not fine tuning. You should have by fine tuning means you should know every layer, what is it coming out, right? So in RNN, what you will do? So you know what is the output of this and what is this output? Output means you don't need to know what is the output. You should know what is the matrix size, right? M and N. And your adapter should take this M and then prepare some output, which is maybe A cross B. And that A cross B should be matching with this actual requirement, which is coming from here, correct? So that it will get added. So here it should have been A cross B is your matrix. Okay. So your adapter's input should be M cross N and output should be A cross B. So to understand that, you should have this matrix, the complete skeleton with you, and to get this output here and see what is the embedding. Understand? So, and all those things done, then only you can design a good adapter. You got me right? Goodbye.
Yes, sir. Yeah. Thank you, sir.
Yeah.
Yeah, I mean, actually to actually continue with the same thing, like actually as an individual, actually can it actually take a model and then actually add a adapters and then actually fine tune, or like I mean it can be done I mean only by in the enterprise system assuming companies, sir, or as an individual, can I mean actually can we
Mhm.
do
You
that, sir?
see, if you want to do a fine tuning of this 8 billion parameter, Llama 3 8 billion, it's a very famous fine tuning worth model. Meta gives you the complete model to in your hand. You can take the complete model and change the architecture, right? Right.
So
So your requirement is only 6 GB RAM. I hope everybody will have 6 GB RAM, right? Nowadays, you can do it in your laptop.
oh, so I mean, actually using Python, I mean, you're saying we can do this, right? So, like,
You can
or
do
some
it
code.
in pure Python. Ideally,
Okay.
if you're a tech guy, you should do it in pure Python. But okay, if you are okay with using some libraries, even in Python, some libraries are there. So see, what are all, there are so many libraries to fine tuning, right? Inferencing and fine. What do they do? Just that some part is written in C++. I agree with that part. Other than that, everything is just logic. What I told you, if you know, you will know to optimize it, right? What is exactly happening inside that. Otherwise, you can just call one library like Hugging Face, Transformer, or any library, and then just put your data set into that and then give the model. it will do a whatever is predefined way of adding the adapter or adding the this one. But in LoRa, you don't need to worry about where to add the adapter, right? So because there is no adapter in LoRa, only choices you have is like which one of the weights you have to choose. W, Q, K, V, and O, and then what is the rank you have to choose for each of them. Correct? That's the only thing you have to choose. So in that case, it
Yeah.
will be very easy. Hmm. But in adapter case, you should know the actual skeleton. I'll suggest if you know the skeleton, it is good for many other reasons. It's not like if you want to do like you want to do research, it will be very good interest. Other than that, I don't think any other because skeleton more than skeleton, as I always say that it is better to know the pre-training data of the model more than skeleton. Also, one more thing, if you are having taking a see most of the cases when this fine tuning and skeletons are important is when you wanted to save costs. Now, if you go to a company, everybody would have fine tuned the model, right? And
Okay.
but
Okay.
the amount of money which is going to get involved will be high when you wanted to frequently fine tune. But if you wanted to save money and your company is interested in saving money, or you wanted to save money and use only less hardware, one time fine tuning doesn't matter. But when you wanted to work on real time basis, right? So you have to frequently fine tune. So in those cases, you have to optimize, and all these logics will be useful there. One time fine tuning doesn't matter. You can purchase from one instance and then run GPUs. Okay. But if you are using continuous fine tuning, then you have to worry about all these things, right? So that is why when you wanted to go for production systems, these things will be very useful to save money because you are continuously operating, right? You cannot bankrupt your company or yourself also in that case, right?
Yeah, okay. So I mean, you are saying,
Okay.
assuming normally, assuming companies they assuming take the, I mean, LLMs and then they assuming fine tune, I mean, assuming based on their, I mean, recommend and then they, I mean, deploy in assuming production. I mean, right? So this is, I mean, normal scenario followed in the industry, sir. Or
Yes.
like, I mean, they,
Not
I mean, use.
always. Yeah, tell me.
Yeah, yeah, or they mean use the, I mean, let's say, I mean, assuming APIs of the, I mean, chat GPT or I mean Gemini to, I mean, actually plug into the into the actual code to I mean design their I mean chatbots.
No, no, no. That is different from this, right? So I will. Did you understand RAG?
Yeah, yeah,
I
yes,
took this
yeah, yeah. I mean,
question.
yeah, yeah. Through the, I mean, RAG, I mean, they can achieve this, or I mean, they have to, I mean, fine tune. Right, sir.
और नहीं है
Either.
और नहीं है और नहीं है फाइन ट्यूनिंग इज डिफरेंट फ्रॉम रैग इज नॉट लाइक फाइन ट्यूनिंग करो रैग नहीं चाहिए रैग करो फाइन ट्यूनिंग नहीं चाहिए इट्स अ वेरी लॉन्ग लॉजिक रीड आवर स्लाइड्स इतना मेहनत करके स्लाइड बनाया है भाई go through the slides you will understand the
Okay,
difference
okay.
between fine tuning and rag. Okay, don't consider that it's like fine tuning. If I do, I don't need rag, or if I do rag, I don't need fine tuning. No, it is both are wrong. Only fine tuning will serve some purpose. Only rag will serve some purpose. Both rag as well as fine tuned model will give you better results in some cases. So
Oh,
it depends
okay.
on the cost and how well, what is the data, how much is the batch-wise data, how much is the real-time data, and how much real-time data you are getting, like how frequency of data. There are a lot of other reasons, and whether your model can be fine-tuned. Like if you are using GPT, then you cannot fine-tune, right? And you can fine tune like GPT-3 or 3.5 or 4.5 also you can fine tune. Azure gives you an API, but paisa bhi katega na. They will take money also, right? So again, it depends on real-time data whether you have to fine tune or not. You can fine tune, but point is, if you have money, you can fine tune, but you have to fine tune also. Question, same thing I will contradict also. You have to fine tune, but you don't fine tune every second. Like in real time
Okay.
data, every second there will be hundreds of data points, right? So you cannot keep on fine tuning your model. So you apply RAG there, but it's not like you okay applied RAG, so fine tuning is not possible. No, that is incorrect. You will do fine tuning, but you will not do it on real time. You will do it once in a month, or once in a week, or once in a 3 months. But you will use RAG along with that fine-tuned model. The final result may come from the fine-tuned model, or the initial decision makers. You can use it for fine-tuning. Understood?
Yeah, yeah, yes, got it. Yeah, yes.
Got it, right? So that's the
Yeah,
point here. So you
yeah, yeah,
should,
yeah.
it depends on a lot of other parameters. Like it's not like I am using fine tuning every month means you should also do. No. If cost is the very less factor for you, then you can fine tune every day also. And more data is coming and client is willing to pay a lot of money, you can fine tune every day. So every day 1 hour you can fine tune, spin up the model and then redeploy it, right? Or you can when it is getting fine tuned, you can keep the other model, right? So something like that you can always do. Or if your
Yeah,
data is incoming is very rare, then you can fine tune once in a while, once in 3 months, once in 6 months. But you have to keep the RAG if it is in real time data is coming in. But even though you are using RAG, fine-tuned model will, it is like double check, right? So it's like your model intelligence itself knows the data. That's the LLM, right? Your fine-tuning means intelligence only does understand the more numbers. GPT will not understand your domain data, right? If it until you are a very general domain, like HR or something, these are all very general domain. Everybody out in every books are there. But when you are talking about the data points coming from rig or somewhere, it will be very specific to them. So GPTs or Gemini will not much understand. It will understand, but when you have a fine-tuned model which can understand the language, it will be faster. Otherwise, you have to go for 1 or 2 rounds or thinking logic you have to put. You'll waste time. Like latency, if there is a problem with latency. Like Gemini, you can put a thinking model 2.53 Pro. It will take 1 minute to respond, right? But when you have a fine-tuned model, you don't need to make it thinking also because it already understands your language. It will give you in 5 seconds. But cost is you have to fine-tune. Everything
yeah,
comes with the
yes.
cost. Okay.
Yeah, yeah,
Yeah.
sure, sir. Yeah, yes, sir. Got it.
Okay.
Thank you, sir.
Think in lot of other ways. Okay. Chalo. Let me take 1 minute break. Then we'll start with some questions. Okay. Okay. Mm. Okay. Just this question. Mm, hmm. Oh, these are all in PPTs. Okay. So this is the first slides, right? The first lecture slides. So we'll see some revision quickly. Okay. So note down these very carefully. Okay. So this will be giving lot of informations which will be useful for you guys for next week. No tension, just enjoy the study. Okay. No need to worry about. So this one sentence I want to ask, very quick one. Is this subject very complex or it's easy? Any thoughts on it? Anybody wants to share something? Whatever it is, fine.
Interesting. Interesting.
Interesting.
Very interesting.
Correct.
Very interesting. It's not
Correct.
tough or so as
Correct.
like we as how we like it. If
Mhm,
we if I see I like this subject very much. I enjoy
mhm,
reading it, even though if it is complex. I am
mhm,
happy to search for the taxonomies and the terms, find out what is going on here.
mhm.
That's happening actually with the conversational AI, honestly.
Great. Okay, good. Any other one more thoughts if anybody wants to share?
Sir, I
Fine.
mean, I feel like
Mm-hmm.
initially I was actually uh,
Mm-hmm.
going through all the lectures. So mostly, I think it's theoretical,
Mm-hmm.
majorly. Like, how do we, like, what are the methods and how do we do it? Actually,
Mm-hmm.
how it will be done is not very. I mean, uh,
Not
understood
very clear.
from the, yeah.
Yeah,
So practical
very
point of
good.
view, I think, yeah. So that
Mm-hmm.
is something which
But I
we
will tell
have
you
to
one
actually,
thing.
yeah. Sir.
Uh, hey, you don't need to work on this. I will tell you reality.
Okay.
Now, as on date, ideally, so that's a very old style. This is a very old style. Somebody tells you hands-on, all those things are old style. Okay. So I am more, I am old person, not very old, 40 years, but I can tell you, I am more with the trend than this question, right? So I don't know. So how I code also. Yeah, I'm a manager. I do hard code, like hard coding, like very complicated agentic workflows. There was one. Just will take 30 more seconds. There was one very complex database. Okay, so the nobody could understand in my company. It is around 2066 tables in that. Nobody could understand that. I just took one day to understand the complete database, all thanks to agentic workflows. It is that fast. It's just that I am a AI architect. That is different. I'm a manager for namesake. I and first of all, I'm not good at coding. Okay, but I know to ask the right questions. I am
Mm-hmm.
very damn deep into the core concepts, right? I
Mm-hmm.
can surely bet on it. If you know the core concepts, you know where to apply what. It's very difficult to find out. It's not very easy what I'm saying. It's as I say, you have to
Mm-hmm.
practice it. You have to think of all the concepts in every other scenario. It's like you have 100 concepts, and every scenario you have to break it into small problems and try to fit any of the 100 solutions there. So it's like permutation combination. Like if your complete database is big stuff and you have to apply your concepts, and it will not be like one concept at one place. No, you can have three concepts for one place and it has to iterate. So point is, if you know all the concepts and if you know what your coding system, what are all the facilities available, that is enough. You don't need to sit and code. There is Copilot to do it. There is cloud code to do it. आज का generation में you should not even think and sit and do. I'm telling you the LoRa concept, right? So you just simply take this 8 billion format. Another 2 hours, I can build a completely personalized code without using any production, any library in Python. Simple Python language, I can use and write that adapter code without knowing anything about this model. Just that I have this model and I'll feed it and then tell it what to do, right? So while telling what I should do, I should tell the LLM will not decide. Okay, LLM will decide what you are telling it. If you simply tell, okay, build a LoRa code, it will build you. But that is not what I wanted. What I wanted is build the LoRa code. You have to tell various points like uh, when to keep, after feed forward I will keep, before feed forward I'll keep, and how much is the size. You have to tell it. Okay, play with the size, play with the layers. How many layers you have to keep. The only the front layers you want to keep it, the back layers you want to keep. So you have to tell, only telling. Bas itna hi chahiye. Only thing is you should know that okay, it is possible. You should not tell LLM, okay, kuch bhi kar lo, right? And even I have tried that also, like initial days. You tell that, okay, LLM, you decide. This is what I want to do. This is the schema. You decide. It will give you a very stupid, I should not use stupid. It will give you a very vague one logic. That logic is not correct. That is why you should know the concepts. You should know the concepts. You should know where it is feasible, where it is not feasible, and then you tell it to do it. But again, you will not tell just one direction to it. You also know maybe three or four concepts might be applicable at one point. Till that filtering you should do. Okay, that is uh, for that, not that much only you need the knowledge. You don't require the knowledge to implement, or you don't require a very high level knowledge. You should have a mediocre knowledge of each of the concept and where it can be applied. Even if you have never applied, the remaining part it will do. Groundwork it will do. Okay. So that's why you don't require, but still doing it yourself also helps many times. Okay. And use a good LLM. And another thing, last but not least, for decision making. Okay. Fine tuning, you can take a small
Understood.
LLM. Okay. Okay. That's one advice also, apart from. Okay. We'll go through, don't worry, we'll go through very important questions. Most probably very high hit questions. Okay. So this is one very important thing I want you guys to remember. Okay. Most of the questions will be what I wanted you guys to remember. Okay. Because the first important requirement is this is a memory based, like you go without any open book, right? So my questions will be exactly what is required to be remembered. Okay. So this is one thing which you have to remember. Okay. Just remember that. Just note down that I'm not going to ask anything. Just go through all these examples, right? So all these 3 or 4 slides, which talks about these 7 stages of a pipeline. That's the main thing. Okay, that's the main conversational system. In this slide, there is nothing more apart from that. Okay, so let's go to the next slide. Mm, Okay. So this is the slide. In this, you have to know encoder, decoder, and encoder decoder models. Okay, so what is it? What is an encoder model? So that is a very core thing. You even in my interviews, I ask this question. Many people who claim that they have used LLM, they do not understand what's the difference between encoder and decoder, and they want to become senior data scientist. How is it possible? I'm GenA specialist. Okay, so it's not right, right? So encoder and decoder, what's the difference, right? So what is encoder used for? What is decoder used for? Without this knowledge, you cannot say that you are applied it RAG. If you say, I will surely reject. Okay. Same applies for anything. Because if you know that, you will know how to make it better. That is why you should know. It's not like I am just reviewing for my selfishness. Okay. So if you know what is an encoder, what is the decoder, what an encoder does, you will know how to improve it so that it will create very good context embeddings for your particular domain. Okay. That's why you should know. Another thing is this one. The difference between BM25 and TF-IDF. 100% it's a requirement from me. Okay. So you should know what is to be done. Okay. Third one is my favorite topic is the HNSW. Okay. So uh, if you know HNSW, why it is my favorite topic also I'll tell. HNSW is really merges the graph concept into the vector search. Okay. So whoever knows what is HNSW will accept my sentence. Okay. Go read about it. And also this one. This is a simple logic. So just remember this. This you should know by now, right? You should not even worry to remember it, but learn it. Okay. So coming to HNSW. Why H sorry. Why HNSW is you are bringing the goodness of graph into the vectors domain. Okay. So earlier to this, vector domain was separate and a graph was separate. This is where you brought the graph into this, because graph is my favorite subject. So vector, they applied on vector. That's a very interesting subject. So very important is this. Okay. Other things you can read for your own knowledge, but this is the best because it goes for production, right? So this you cannot take it for production because of some issues. You should understand the issues here. Okay. And this has a very low recall, but this has a very high memory, but really very good recall and very fast queries. That is it. The advantage is the graph part. Okay. And no training is of course point. So learn HNSW as much as possible. If you didn't understand me, go watch some YouTube, learn it. It is the best thing you will appreciate in this course. Okay. And what else? Anything else? Yeah. Mm, done. This is done. Okay. This is all I have discussed, right? So PQ is done. Sorry for scrolling fast. I can understand from that side when somebody scrolls the page other than us, it will be very irritating. But sorry for that. Okay. So this one I said, right? So BM25 and TF-IDF, what is the difference? Okay. So I'll tell you the answer also. It will be two things what you should remember is these two. Out of these three, you can write first two is also fine. Okay. So where it scores higher, you can just go read about it and also learn the difference between dense and sparse. Okay, so what is the difference between dense and sparse? We discussed in class. Just go through. Okay, so that covers the complete this slides. Yeah, I forgot. RRF also is there. Okay, so just remember this. This is a very simple. This looking like very complicated mathematics. It is nothing. Okay, so when you do a calculus, I think you can do a hand calculus. This page is there. Just go through this. Okay, this is the most simple. It is like I want to give free marks, right? It's like free marks. This much calculation is nothing. Right? So just that divide and keep it four decimals. Four or you keep sufficient decimals. Okay, you don't need to give five. At least four decimals you keep so that you don't just write zero point 0.0 for all. 0.0 for all. Okay. So just ensure to go to four decimals. It should be sufficient. Okay. I think that's all from here. Third class. Mm, I think third also we had the same thing. Fourth one should be models, landscape. Mm, oops. Okay. Oh, fourth one. mm, Fourth one I didn't consider much because of this is all too much complex. Only few things I've taken. In this only encoder decoder will come, right? I guess. No, no, no. Here mixture of models. So I've not considered any questions here, much of this. Here this is a question. Okay. So just remember this. This is a very basic stuff. Again for free marks. Okay. Free marks means, sorry to say that. It's like free marks means easy marks. Okay. So you know this thing. So remember to calculate. Okay, it's very basic stuff. It should be a very basic question. Okay, you just have to remember this. Okay, whether the numbers will come or not is secondary thing, but remember the formula. Okay, so if you know the formula, most of the work will be done, but just practice one question out of it. Okay, that should help. And if you remember, we spend more time to discuss why the complexity is n square. Remember that also. Okay. I think if you will listen to the class, most of the things will be clear. And if you want to go deep, you will. If you didn't understand class, you can watch some YouTube videos also. Okay, this and all is not there. Mm, Quantization will be there. So today's also we saw a little bit, but earlier we discussed it in detail, like it's mentioned here, right? So how it is, you don't need to calculate. Will not tell you to calculate again. So again, I'll tell you why I didn't want to see. I remember 3 semesters before I asked a question to quantize the something. Okay, it's a small thing. I didn't feel that is a requirement as on date. You give it to GPT, it will do, right? So you don't really require that kind of knowledge. I don't want you to sit in the exam and calculate and you miss out one number and you lose marks. That is not real testing, right? You should know what it is and why. I told you earlier, right? Few minutes before when we are discussing about quantization, why you should know quantization and how does it help? Like, how does it help you to decide whether to do a fine tuning and based on your hardware availability in your company or not? Purely practical. Okay, so that will be the question also. Think in that terms. How does it reduces the memory and when we can decide the inferencing and the storage. Okay, simple logic. Okay, nothing beyond the what do you call this shown on the slides will come. Okay, and also you don't need to remember everything in this slide also. So don't need to remember all these things. Okay, so nowhere it is asked. Okay, just remember FP32 is there, BF16 is there, FP16 is there, FP8 is there, NF4 is there, and 1.58 bit is there. Okay, so I think 1.5, I think it is not asked, but you can remember it. Okay, it is not there in the question, don't worry. Okay, and these two things you should know the difference. Okay, so it is activation aware, and then this is post training quantization. Okay, so what is the difference between? So it's like you know what is the activation before you fine tune. This is more of LoRa, and this is like after you have trained or fine tuned, you just simply quantize it. Just after quantization, if you use it for inference, then this is GPT. Okay. So here it is like you quantize it and then do a training on it so that you improve that quantized model and then you use it. Simple, right? Hmm. So this is where we discussed about LoRa. LoRa and QLoRa, you should know the difference and advantage. Okay. Okay. Difference. Okay. So quantization plus LoRa fine tuning is QLoRa. Okay. And what is the difference? So you can just read through it. This is this I lost. Okay. Mm, mm, No, this is not there. Not to worry. But you should know what is KV cache. KV cache, prompt caching. So these two things you should know. Okay. So remember that KV cache and prompt caching you should know. Okay. Just go through these slides. Mm, Others are not there in this. Prompt cache. So mainly prompt caching, KV cache. Okay. So and other than that, this is done. So let's go to the 5, 6. Hmm. So in this First thing is you should know what is JSON schema. What are we talking about, right? So what is the difference between JSON schema and a normal LLM response? That's what is this page. This slide you should know. Okay. So why we wanted that JSON schema, right? So I hope everybody knows that, right? So by if you have just attended the class, you will know why we wanted a JSON schema. That's where we go to production. I think that is what we have written. No, not written here, but that is the point. So if you want to go for production, JSON schema is required, but that is not the question there. Question is what is the difference? And you don't simply write you want to go to production. Okay. You should write this word in that question answer. Function calling. Function calling, parallel function calling, and sequential. These two difference you should know. So we discussed this sequential and parallel. Why we have to go for parallel and what is the advantage, right? So advantage, like you will save time, but how can we do that is where the JSON schema helps you, correct? So that is what we discussed here. Please remember that. Okay. This is okay. This is like this you should know not for exams. You should know for your agents also. After exam, there will be midterm classes, right? So lecture 9 onwards. So you should know this React framework. Okay. So I think we have this one. I want you to draw this. Remember this and draw this. Okay. And then put one line. I think line is not missing here. Wait, wait. I think there was one more diagram. Draw this. Don't draw that. Draw this. Okay. If you draw this, you will get the marks. Okay. I already told you. This is simple, right? Just that you have to remember and draw. Right? Anything else I missed here? Nothing. And chain of thoughts you learn.
Um,
Okay.
question
React
here.
and
Yeah,
yeah. Tell me.
may I ask? Sorry to
Yeah,
interrupt.
yeah, yes. Mm.
We are going to write the exams in paper and then upload it, right? That's how we are going to do for conversion. I don't see any other instructions.
Yeah. That is how you know. Because you have to
Yeah,
draw means how you will draw it there, right?
that's where that's why I
Mm,
got this
mm, mm.
question. But
Yeah.
audio analytics,
Correct.
we have to type it in that space given in the
Mm.
screen.
Yeah, I
That's
think
what the
you can
instruction is.
type for some of the questions where you feel that only answers are there. Even when I was doing it was like that, but I have never typed it. I always feel writing, I will draw something, I'll find a way to draw some diagram
Yeah,
so I can write
it's the
more, right?
habit of us, like, when we touch the paper and
Um,
pen, that's when like the flow will be there for me at least.
correct,
It's
correct,
my
yeah,
psychological feeling. If I
correct.
start typing, like, I'll stuck somewhere. So
I always
thank you.
had doubt that whether if I type and submit, it goes or not. So I always write it and scan and send. Okay.
Got it.
So
Yes.
better to have that, right? So keep it that way. And you don't need to remember this cost analysis, this and all just for your learning. Okay. So most of my slides are for your learning. Okay. Only few things which I mentioned in this complete thing slide, JSON schema, sequential and parallel calling difference. Okay. And the React framework. Only three topics, right? I think you can study in half an hour with this. 7, 8. Oh, this is this one, right? Okay. This is after 5, 6. This is 7, 8. Looks like very less content, right? Okay. But I have covered everything. Here it will be little complex. The prompt engineering, which must say engineering. One important question I will tell later. This is done. Okay. Some understanding of your this should be there. Okay. Understanding means what I want to say here is when do you have to use tool? Okay, so learn that. Okay, so when do you want your LLM to use tools? get the answer and then come. Okay. It is there in the slides as well as I mentioned many times. Just go through and give it. Okay. And cosine similarity we discussed. PFT, learn about the LoRa and QLoRa. Okay. So learn completely LoRa and QLoRa, learn what is the difference. Okay. And in QLoRa also learn about the quantization. And there is one concept called double quantization. Don't forget to learn. Very important. Okay. It's not a very big thing. It's a very simple thing. It's just that you're little more optimizing the memory. Okay. So learn double quantization in QLoRa. Okay. That will be very useful. You will appreciate why that concept is there. At least for that you should learn. Even if you don't want that 1 or 2 marks extra. Okay. Now coming to this one. COT, TOT, I didn't ask. Let's keep this for final. Okay. Mm, This is very important. Whatever I discussed in this page, right? So please do remember. Okay. So this is the Instruct GPT, right? So this is the main paper comes from Instruct GPT. Not self Instruct GPT. Okay, so Instruct GPT was created like this. Okay, so using the 3-step method. So what we do in the first step, why we do, most important, just don't simply draw these diagrams and come. Okay, so why we do and what we do. Okay, what we do and why we do. Those two things. Most importantly, why I mentioned this is write it once before you come for the exam, because it will take more time, because this will require a lot of understanding as well as crisp way of understand like writing. Okay, so if you don't write it once before coming to the exam, you will take 1 hour for writing the answer for this question only. Okay, so just that you should know to explain the 3 steps with an example. Okay, and then detailed way, but in the right flow. It should not like miss out something. Okay, so the flow between step 1 and step 2 is most important. So anyway, flow between 2 and 3 will be there. 1 and 2 is very important. So give your own example. Don't take just the same example. And one more thing, a warning, what I will give you is that whatever is there in this slide will have mismatches between 1 and 2 and 2 and 3 also. Little bit. If you don't understand the concept, you cannot explain it carefully, correctly. And that is what exactly we will see. Because if you can explain that integration correctly, means you really put pain in understanding. So that's my style. Okay. Maybe it is a very bad thing, but that's my style. Okay. So I want you to put, it doesn't take so much time. If you will ask me, like if you go and learn maximum 1 hour worth of that time. So then you should understand how much mark it will be. Okay. Uh, then instruction reading again. Reinforcement. Reinforcement means you should learn. Again, this is discussed. We discussed this again. So remember that this is very important. This is second and third step only. That is why this complete slide deck, 1, 2, 3 steps are very important. And in this reinforcement, you should know PPO. As I already mentioned, you don't need to remember any of the formulas, but you should know what is PPO, what is DPO, and what is GRPO. Okay, you remember that. And as I already also mentioned, when is which one to be used when. Okay, 3 concepts: PPO, DPO, and GRPO. Okay, so remember that. I think that will serve the complete RL. It's already there in the slides also, a little bit of comparisons and stuff. But your understanding will give you little more confidence also. Okay. See, always remember it's nobody's interest to give less marks. I always tell everyone to give maximum marks possible. except that they didn't understand. I see others give key points. I tell what exactly is a catch point, which is really required for a person who understood the concept, not simply written. If I ask you about dense retrieval, simply don't write anything. Okay. So if you have listened in the class and understood the concept or learned from YouTube also, if you understood the concept, you will surely integrate it correctly. And that is the point I wanted to capture. That shows your knowledge, right? So this is a motivation. Okay. You can scold me, doing, tell me anything, but point on at the end, I want you guys to remember all these things. That's how we learn, right? So by scolding. Exam time में frustration होगा, so you can scold your prof and remove the frustration, but later we'll all feel that okay, that was a good thing that we learned. Okay, in fine tuning, as I already mentioned, right? LoRa and Q LoRa will be there, and not the complete stuff. Another thing, mathematics only few things that RRF, cosine similarity, very simple things. Okay, just don't make mistakes in that. It's very simple mathematics, right? Not even anything about mathematics. I don't want to complicate life. Mm, HNSW, right? DPO, PPO, GRPO, right? And then agentic pipeline, 7 stages, correct? And why tool calling is required, React loop, right? And understand that architecture, right? Dense, that second lecture, what we saw, right? Uh, what is dense retrieval? What is keyword retrieval? And how do we do this hybrid search, right? And what is the difference between BM25 and the TF-IDF? Second lecture is like rich of, that is what is RAG, right? So that's a very rich lecture. Okay, I guess I am done. Prompt catching and KV cache, right? These two we can do. Bas, I think I did justice to you guys. No scolding, okay? And toppers don't feel bad. Don't worry. Doesn't matter. I will ensure everybody gets maximum score. Okay. And as I said, see, the only thing, see, I have already told you what are the questions, topics, right? So that will help you. The difference will be only those topics, but who understood very nicely will be visible in the answers. That's the art of our evaluators. They will ensure. If at all anywhere you feel that somewhere evaluation is less, please do ping us or just do a re-evaluation. If you genuinely feel that you have justified the answer, and think about your studies also, you have really read and think, understood the concept, then ask for it. Okay. So we will surely give. Okay. Not like you ask for a research, and don't make it delay that. Okay. So don't ask just before comprehensive exam. Don't ask for, okay, that question I missed because I went for a business trip to Europe, UK. Because the exam that duration will get closed means we cannot do anything, even though the answer is correct. Last time I say ek banda came at the last moment, even though his answer was correct. I could have given him 1 or 2 marks extra, but he came very late when that is closed and the marks have gone already. Right? It becomes very difficult. Right? We cannot spend so much time like that at the last moment and think everybody comes like that at the last moment, then it will become difficult, right? So please consider that also. Don't miss out the time. Be just 5-10 minutes is required for many things. Just spend that time. Don't tell me time is not there. Business trip में है. Business trip में थे, don't you talk to your parents or wife? It is that important, right? Career is important. You have paid money, right? So 5-10 minutes तो निकाल ही सकता है. ठीक है, चलो.
And
I
you are
may be
very
biased
generous,
here.
very
Yeah,
generous in that, sir. I see that like you allowed few people to write the quiz also.
yeah, yeah. फिर भी ये लोग will tell something. Yeah. You know, that was the funniest email I got. So I remember I got so much irritated after reading that email. You remember, I opened the quiz on, I think, 1 week. Next weekend means 1 week time I gave for all those people who have missed it to message me or email me or in a general email also, support also. I have taken all those things. I opened in the next weekend. Again, there were some misses there, and misses means those who again afterwards mailed. I opened on the third week, and at the third week, even that one guy has missed, and his email could have been a very polite email. And the email, what he wrote, it was so very bad that what he mentioned, I'll tell you, after opening 2 times, 2 weeks, 2 weekend means I went 2 weeks for somebody to respond. What he wrote was, he told in the yesterday, that was Saturday open, Sunday, and it got closed on Saturday itself. Sunday he mailed that Saturday you have opened quiz only for 3 hours, and it is not acceptable. Because every other course, people are opening for 1 day, and you have opened for only 3 hours. I didn't know whether to laugh at this or worry about it. I just told him that this is the third time I opened the quiz, and this is just 3 hours window for only those who wanted to complete it. He was like,
Sir, may I ask
Sir,
you?
I
coming
think sir, he
back.
was sleeping for first 2 weeks and then he got up in
Yeah,
the third last
exactly.
3 hours.
Exactly. That is
That's
what I
what
asked.
I
Till now, you have not
yes.
even opened any portal
Maybe
of
he
your.
was on a business
Uh,
trip, sir. Maybe he was on a business trip for 3 weeks.
अरे कुछ भी है चलो
And I want to
ये
Sir,
appreciate
may
सब
I
you on
ask
that,
a
सुनना
sir.
पड़ेगा ना
question?
like I am like a culprit is just quoting me and marked
So no,
everybody
Bhagat
in the
sir,
bits.
appreciated you open that, and I was a person who take a, the chance. So thanks for that.
Okay.
You opened the
Yeah,
second time, right? And you
yeah,
corrected
yeah.
my email as well, if you remember.
Yeah, 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 I remember, I remember.
So thank
Sir,
you.
So
may I ask
Yes,
I
a
yes.
think no one in
question, sir?
Bits actually never care about our mails actually. Even we send so many mails
Okay.
to so many people till now. Nobody cares, sir. I want to appreciate and
Mhm.
thank you for that. You're
Oh,
taking care of
thanks,
you.
thanks.
You're
Sir,
caring for us.
I'm a
sir,
manager na.
this
I
is
have to reply all emails. Otherwise they will escalate. All right.
so this is our third
Sir,
semester. I've never
it's
seen any faculty doing that. So I really appreciate your flexibility. It could be a genuine cases for some of them, but I hope
Mm,
people do not take undue advantage of that, flexibility and generosity from your side. But I've never seen that earlier. It's really appreciable. Yeah. Thank you.
yeah. Thanks.
Sir, may I know when can we expect the
sir.
results? Quiz results are
Which
not
result?
out. Quiz results.
Quiz. Like quiz
Yeah.
ka, okay, I'll open it. Maybe I can open it now also. So why do you want to know? It's whatever score is score, right? This is 5 marks. And no relationship between quiz and exams. So it's just a score. I'll open it maybe most. I was thinking I'll open it by after mid exam. So
Um,
that's why I
Bhagat
didn't
sir,
open.
there is a
Yeah, yeah,
Bhagat sir, there is a
yeah.
question from my end. Like, so this is really not related to the topic what we are talking right now. It's off the topic and
Mm-hmm,
it is related to the subject.
mm-hmm,
Recently, John Hopkins University, Mike Bronner group, the team,
mm-hmm,
uh,
mm-hmm,
discovered something. I think like you might have heard about it. It is interesting discovery, like how the human brains read compared to the normal trained LLMs or SLMs or the how it reacts. So they
mm-hmm,
compared three models. One is CNN, one is agentic, other one is transformers. So these
mm-hmm,
three they have compared, and out of that they found it like the CNN is the one like which acts really very nearly close to the human brain. They actually used
mm-hmm,
one use case that they showed only one cat photo to the three of them. So
mm-hmm,
the agentic and the transformative really doesn't understand what it is for the first time, and it failed the test. But CNN, after looking at the cat picture, it started realizing many pictures. It's related to the cat, which is in a different context and a dimension. which is actually
Mm-hmm.
really very near close to the how children get understand for the first time what is the cat after looking at a cat for the very first time. So this is an interesting study. The based of the study, what the outcome they got it is that without even the data, huge humongous data, if we properly architect a AI system that is very close to the human brain and it will act and react based above the context. Have you I mean have you gone through this? I mean if you have gone through it, like now could you please help us understand your side of the world of how you look at it?
Mm-hmm. So in a quick way, I can tell you, we are out of time, but on main point, what I wanted to say is, yes, I read about it. See, one thing which I always believe is CNNs are better than VATs. Okay, vision models, right? Vision
Right.
transformers. So for images and mostly images, right? Vision best is the CNN. That is for sure. Even today, even for all the vision type of deployments, in my projects, we use mostly CNN only. CNN means not pure CNN. There is some like augmentation with text. So CNN part only understands the image, and we have the other part as text to token converter. I know, I hope you understand, right? So vision type.
Yeah.
So even
Yeah.
vision models do that only. Most of the
Correct.
VATs, if you see, the image understanding is done by CNN. So
Hmm.
CNN is more good at understanding the uh, what do you call the complications we even without training much training. So as you also told this point, right? So but in the textual world, still transformer dominates. You cannot bring in CNN there. Okay. So transformer will dominate as of now. Maybe there are some better models coming up. MOE. MOE also is like MOE also has many of the transformer. Transformer means what we are calling is attention mechanism, not the complete transformer. The transformer's main logic is attention mechanism, right? So attention mechanism still holds good. Maybe you can make it sparse and a lot of other small adjustments, but the main logic of attention mechanism holds good for textual world. But for image world, yes, CNN nobody has replaced till now. I agree with that. I'll go through a little more, maybe more understanding on that. Maybe we can discuss in next class.
Yeah, it's completely they are based off of visual bio technology,
Mm,
neurosciences. Neurosciences group is what their specialization is, but they were trying to find out which one could be
mm,
dominating while it comes to close to human brain.
yeah,
But yeah, so
but
as
we
you said,
cannot
like no,
every.
see,
Uh, yeah,
no, please,
yeah.
please
Tell me,
go.
sorry. No, no, please you go ahead, sir. I was thinking you
Thank you.
completed. Ah,
As you said, like the CNN,
mm,
like you have also manipulated while using it, manipulated
mm-hmm.
this, customized it based
Yes,
on
yes.
what is the need of from your
Data set.
projects.
Yeah.
Yeah,
Mm.
so correct. But the
That is
data set
tweaking
sizes.
has to be done.
Mm,
Tweaking the architecture of CNN itself is an art, according to me. So if you tweak that architecture very nicely, right? So why nobody see you bring in any transformer, you cannot beat SAM model, SAM 2. Currently, I think SAM 2 is there. SAM 2 model or the YOLO model, YOLO V12 has come, right? Nobody can beat it on the image detections and the speed also. And transformer, as you all know, that the complexity is also very high. But in CNN, that is not so much complex in that also. The time consumption, real time analysis of this is very good in that. And of course, most of the things are visual, right? So as we are, most of our humans like mostly we interpret things by looking at it, right? So it will be the most important thing. Transformers became hit because of textual world, right? Text. mostly texts are there, right? Books and all these things. But it struggles, in fact, for scanned documents. Scanned documents, it struggles a lot. So you can bring in some good CNN. Most of the models, VAT models are having CNN, a part of it. So ideally, it is not attention versus convolution models. Everywhere, even I always like that last semester also I mentioned, any technology, it is not just one technique. Any requirement, it is not one technique. It will always be two, three techniques. And that too, it will depend on a particular scenario. Like you want to process some 1,000 PDFs. It's not going to be transformers. It is neither going to be the VITs or CNNs, right? So it has to be both because you do not know which document is going to be scanned, which documents, and inside document, which of the pages are going to be scanned, which is not, right? So it again, it is a combination. Our document ingestion system is the most complex system rather than the chatbot which is facing the customer. But people don't, nobody in the company appreciates that back end, right? So people think, okay, you have put some documents to ingest. Arey bhai, we built that for 4 months. Front end is just 2 weeks work, but people will say, wow, that this is the. So that's the main point. The complex and unstructured data, unstructured and unformatted, variable formatting in data documents are getting processed, right? So in that case, it's the combination always wins. Hybrid always wins. Hybrid also, it has to decide on the go. But point
Hmm.
here, I will tell you one thing. CNN is not a good decision maker in terms of requirements.
Okay.
Requirements decision maker is LLMs are good because most of our
Yeah.
decision means inputs are text,
Yeah, there is
right?
a concept to it because LLMs
Mm,
go under the generative stuff. It is going to
mm,
generate. It is
mm,
decision making is a discrimination. Like, okay, whether it is yes or no, it will fall into
mm,
the group or not. So there is a difference in the way
mm.
what is it is mean for. So what you are saying is
Correct.
correct. I 100% accept that.
Yeah.
Uh, so based on your
Chick.
experience,
Yeah.
is there any books or any beginner stuff for architecting this kind of systems? Let's say like some use cases they take and talk about it, right? For this kind of
Uh,
system, the architecture basically you can just an idea overview. If you look at
which
Microsoft
kind of
Pages,
system we are talking about?
it's not very
Document
specific.
injection.
No, it's not very specifically. I'm looking at one use case. I'm looking at in a general context that let's say if you are going for e-commerce, this is what your architecture could be if you are following the microservices. This is based off of
Oh.
the systems I'm talking about. Is there anything like that which you are aware of based off of your experience?
There is no book, specific books for it. You can go through all the research papers related to that particular domain in that particular data science or GNA, whatever you want. I don't know any book for specifically. I guess one book is there, I heard for finance. But again, see, when they write books, right? Why I don't go through books is books are very much basic. At least 70% of the books will be more basics. And by the time I finish reading, it would have already got outdated.
The
Sorry.
basic idea,
Yeah.
I'm looking for the basic idea. I have been following your
Uh,
lectures from last 1 year from our
okay.
seniors.
Oh my God.
This is based off of my interest. Okay,
Okay.
one of the lecture you have been talking about the SLM. The SLMs are
Mm,
very good compared to the LLMs. We can take it for a small context mod training scenarios, and we can utilize it. Um,
yeah.
when we talk about your use case, your problem solution on looking at the database, which nobody knows about the 2000 tables,
Mm-hmm.
I have been relating to this, like why you went for an that the transformers not to go with an SLM. That SLM will stay as a BA for you forever for the future, right?
Mm,
This
correct.
is
Correct.
what my concept comparison. Why you went for the
Mm-hmm.
transformers to resolve only for that moment? Why can't you put a SLM, stay in there, answering anyone who is asking about the database or any table, to be very specific.
Oh, okay.
It will,
Uh, for the 2000 tables you're asking, right?
yes,
So for
yes,
that, why you are asking why LLM and why not SLM?
yes. I
Is
mean,
that the
my point is
question?
that correct. Yeah, it's a large language model. As we know, the concept itself
Mm,
is a
mhm.
large trainer. It's a large training
Yeah,
set, fine tuning.
yeah, yeah.
SLM is not.
Correct, correct. So I'll tell you why I did that. So because it was not simple direct calls to SLM. So what I had to build was a perfect graph out of the tables because all are nested tables, right? So every table has a foreign key and it is like connecting with a lot of other tables. So I had to create a graph to understand this stuff first of all. So I built a graph, and for building the graph, I have to, there are two steps in building a graph. You have to resolve the entities, right? Entity resolution and entity alignment is there. Okay. So for all this purpose, I wanted a big LLM context window because the number of tables very high. If it were 300 to 400 tables, yes, SLM could have served my purpose. Here I wanted a big LLM to ensure that it creates a graph the most right way. There were some missing links. Ideally, I understand. Even after using big LLM to put in all the context inside that, I had a lot of missing links. I had to do some things manually, but it was just 1 or 2 hours work. That was not a big deal. But I could first requirement was to create a graph, and then I started trying to analyze three hops. Three hops, I don't know. Three hops means it's like three connected nodes next to each other, right? So it's like I connect to another node, and that node is connected to another node, like three hops. Three hop understanding of a particular node. So for that, I needed a good context window. Like if the schema, most of my tables were like having 120 columns. Uh, I think highest was around 250 columns around. So most of the columns were also high. So the schema was also very high. So I didn't wanted to risk on the decision because I wanted to do it in a day or two. So wanted to make it fast. So I used LLM. It was not a project for information. If it would have been a project, I would have tried to optimize the cost. It's a good point you noted what I mentioned. It was not a project. It was just one-time understanding of the thing and preparation of the graph. So if next time a new table gets added, it is just one small node connections, right? So for that, I will not require a. It's all one-time connection, and it's not going to be tables are not going to be prepared every day. The rows are going to get added every minute, but tables are going to be almost stable. So my
Sure.
graph was more related to columns, not on rows.
Yeah, I got it. But
Mm-hmm.
this is what the challenge. I was trying to explain you the challenge. Even
Mm-hmm.
after I was going through the conversational AI part, especially your lectures from the last two semesters, I'm
Mm-hmm.
still trying to understand why
Mm-hmm.
and why not when it comes to the specific usage of LLM, SLM transformers. So like that is what actually the challenge right now I've been going through personally. When
Okay.
when you say that, see, you don't, the fear of not to lose the decision making is what
Mm.
is a main factor forced you to go with the LLM, right?
Correct.
But
Exactly.
when I think about this fear of
Mm-hmm.
unknown, this fear of unknown is
Mm-hmm.
what the driven factor, which should not be the driven factor when it comes to the architecture. Please don't get
Correct.
offended. I'm just
No, no,
being
no.
polite, trying
I
to be
am
polite, and
completely with
I'm
you. I'm completely
I'm
with
trying to
you.
understand because you are an
Yes.
expert.
Yes.
This is
Mm.
kind of a brainstorming question, not definitely, trying
There is no
to
fixed
cross
answer
verify.
for this. There is
Okay.
no correct answer, and it actually it will depend on the particular scenario also. Like in my scenario, it was just one-time business, right? So LLM was a better chance because training SLM would have consumed a lot of time, and I didn't wanted to do it. One is time. Second one is I don't know what is the correct answer, right? You understand, right? LLM will do its own work. with thinking power. But SLM will not do thinking. I wanted to train it. I have to train it in such a way that it has to decide on something. So first and foremost thing to for my SLM to be a implementation, like I wanted to use an SLM. For that, the foremost thing is that I should have a training data set. But the database I had in my scenario, the database I had and the graph I required, there is no training data set there, right? So
Right.
that is also
So,
one thing. But in case where you have a training, like for example, one project came, I did a Viva recently. It was like resumes. I think resumes,
mm,
no? No, 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 not resumes. There was one bug fix or something. Bug fix or something. Okay, you can take resume. That was easier stuff. Like resumes, you take candidates, right? So what your people have accepted candidates, you will have at least some 50, 60 samples, right? These resumes have been accepted for a particular JD, right? So as a HR, you will have at least some 100, 200 samples like that. And now you wanted to set up a LLM or SLM. You can set up a SLM to new incoming resume. You wanted to sort it based on your manager, the particular manager's choice. So here you already have a prior correct data, right? What is the correct output? So in those cases, I think SLM can be trained and then one-time implementation, right? So there you don't need a very big LLM to understand every time. Until otherwise you deviate to a completely new field of resumes.
but as you said here,
Mhm.
I'm sorry if I'm not trying to waste your time.
No, no,
Please
I
bear
am
with me for
free,
1 or 2
completely
minutes.
free. I'm jobless. I don't have exam next week. Uh, you guys are to be busy. Now I am free
So,
next 2 weeks.
sorry.
Hmm.
So, in your context,
Hmm.
when we talk about
We'll stop
the
the recording. Maybe it may not be useful for those who come here. They will just tell that 3 hours recording. Okay, let me stop that.
Sure.
Okay. Yeah, yeah.